Hey guys, and welcome back to another episode of my Ability System series. Before we start off with this episode, there are a couple of things that I wanted to mention. First off, I uploaded a version of the whole project to Mediafire, just in case that you're experiencing any bugs or issues and you're not sure how to fix them. You can download the project and you can have a look at it and maybe find your issues by comparing your blueprints with mine. Download link for that will be in the description, and I should like to mention that this version of the project is running on 4.18, so make sure to have that version installed before you download it. Speaking of 4.18, there is a little bug that was mentioned on my Discord server, so I wanted to show you that bug. And that is when we hit play, grab one of our skills, put them on our hotkeys, and you notice if we just try to grab our spell here and move it around, it doesn't work. And that is because Epic somehow changed the way the on-mouse button down function is received, and somehow the button on our hotkey is blocking that. I haven't found a way to fix that yet, but for the time being you can work around that by just grabbing the skill by that little border with the F6 here. So you can grab it here and then drag and drop it somewhere else. So now that this is out of the way, let's start by implementing drag and drop for our skill tree. To get started, let's go into our drag and drop folder, and we will just duplicate our skill drag here by hitting Ctrl and W, then call that widget drag. So we just create another drag and drop operation, open that up. We can remove the from hotkey here and the skill actor. Instead, we want to add two other variables here. The first one will be called dragged widget. It will be expose on spawn, instance editable, and a user widget reference. Then the second variable will just be called custom offset, and this will be a vector 2D, also editable, and expose on spawn. Now compile our recently created class here, save it, we can close it and go to our widgets folder, then go to our w_main tree, head over to the graph. We will override a function here called on-mouse button down, and what we simply want to do is call detect drag if pressed. Connect your mouse event to the pointer event, and the drag key should be the left mouse button. Then you can plug in the return value for the return node here and compile. Then there is another function we need to override called on drag detected. And when we detect a drag, we want to create a drag and drop operation. The class of that will be our widget drag. Pivot point will be mouse down. The dragged widget will be a reference to ourselves, same as the default drag visual. And now we need to calculate our custom offset. To do that, you drag off of the My Geometry and search for absolute to local. And for the absolute coordinate, you get your pointer event and then get the screen space position. You can also get the last screen space position, that should not make too much of a difference. Plug that in for the absolute coordinate and the return value for the offset. Then we can copy over self and remove it from the parent. Otherwise we will have two versions of our widget staying around because one is created for the default drag visual. So hook all of that up and connect the operation from our create widget drag to the return node. And make sure that you're not connecting the absolute to local to the offset, but to the custom offset variable that we created. Alright, then we can remove the wire here by just alt clicking it. If we compile and save, now we should already be able to drag around our skill tree, but if we drop it, it will just disappear. So let's fix that. Let's close our main tree and go to our main widget instead, because that's the place where we want to drop it. Head over to the graph, and here under drag and drop we already implemented the on drop event, because if we drop skills there, they should just be cleared. What we want to do now is, if that first cast here fails, we want to grab our operation and cast it to the widget drag instead. Connect that to the cast failed. If that cast also fails, we can just return with false, but if not, we have to set the position of our widget. So let's get the dragged widget and add that to viewport. And then off of the dragged widget, we want to set position in viewport. We will uncheck the remove DPI scale, hook that up here. And now to calculate our position, we need to get the my geometry here, again absolute to local, and plug in the screen space position as the absolute coordinate. So this is where our mouse is right now, and from that we have to subtract the offset. So off of our as widget drag, get the custom offset, plug that in for a subtraction, and then the result will go into our new position. After we did that, we can simply return and check the return value because we handled that drop here. Okay, if we compile, save this now and play, we can open up our skill tree by hitting K and then drag it around, drop it somewhere and it will stay here. You can close it, reopen it, and we'll be at the exact same position. Okay, close that. Now for the second part of this video, we will start working on our summoning spell. So we want to have companions in our game. First off, if we have a look at our textures folder, there is a folder called companion pack that I created. You should also do that. And if you open that up, there are 4 textures inside. Download link for those will be in the description. So just download the pack, unzip it, import those 5 textures, and then we will select all of them, right click, asset actions, bulk edit via property matrix. Under level of detail, we will set the texture group to UI, and under compression, the compression setting to user interface, then hit Ctrl S to save all of them at the same time. Right, so we've got all of those imported. Before we work on our companion widget, let's go into AI and create a new folder for companions. And because they will work very similar to our enemies, we will go inside of that folder, right click our master enemy and duplicate that, call it master underscore companion, and let's move it inside of our companions folder. Move here. Then we will open that up and it will give you a bunch of errors. Let's have a look at them. We will just remove those conflicted nodes here. We will clean up this blueprint in the next episode anyway, so let's not worry about that right now. So if we compile now, that's okay, right? We want to add a couple of variables though, so let's add a variable here, which will be called icon. This is supposed to be a texture 2D reference. If we compile, we can set a default for that, so just search for the companion icon here. Then we'll go to the name of our enemy and set the default to companion. Set the default level to, let's say, 10. And then we will also add 2 other variables. One will be called lifetime. So the amount of seconds that our companion will stay by our side before it will be deleted. Let's make that a float. Add another variable, also a float, and that will be called pastime. Then compile and let's just set the default of the lifetime to 60 seconds, so 1 minute. Right, compile, save and close the master companion. Then let's head over to our widgets folder again. Right click, new widget blueprint. Let's call that W underscore companion and open it up. Change the setting to desired on screen here. Remove the canvas panel because we want to start off with a size box. The width and height of our widget will be 425 pixel by 117. In our size box, we want to grab a border, place that inside of the size box. It should have a padding of 0, and for the image we will search for the companion BG, so just a simple gradient. Then we'll grab a canvas panel and place that on top of our border. Make sure this is set to horizontally and vertically fill. And in our canvas we can start to lay out all of our objects, starting with an image. This image will just be called the companion icon. It should be a variable. Let's anchor that to the left center here. The alignment in X will be 0 and in Y it will be 0.5. Then we will reset the position X to 0. And our size will be 108 by 108. Z order should be 3 because there will be a couple of widgets that should be beneath our little icon here. And for the brush, we'll just search for our companion icon. Alright, so that's in here. After that, we will search for a progress bar. Add that in our canvas panel here. Let's call it health bar. This one should also be anchored to the left center with an alignment of 0.5 in Y. Then reset the position in Y to 0. In an X, we can set that to 69. The Z order is supposed to be 2 here. And for the size, we will type in 324 in X and 56 in Y. Then let's have a look at the style here. So the background image will be the companion health default. And let's draw that as an image. Let's copy, paste that onto a fill image and select the companion health fill here. Then let's just set the percent to 1 to see how that's going to look like. And it's fill blue. That's because the fill color and opacity here defaults to blue. We will set that to white. Now it's red. That's perfect. Now we will add a text which will display the name and level of our companion. Just drag that in here. We'll set the Z order to 4. Check size to content. It will be aligned to the upper left corner. The position will be 108 in X and 0 in Y. For default, let's just type in gruntling and then in brackets maybe LVL dot for level 15. And we need to decrease the size of our font. So let's take the light typeface with a size of 18 pixel maybe. And just to make it a bit more visible, we will increase the shadow color to 1. And then we can change the color and opacity of our text to some kind of gray. I will just use the hex linear code AB, 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 FF. Alright, hit OK. That's it for the text. Apart from that, we will need another progress bar. This one should be called time bar. It will be anchored to the lower left center this time. Alignment should be 0 in X and 1 in Y. Then the position should be 80 in X and maybe minus 12 in Y. We will set the size to 314 in X by 19 in Y. Z order can be 0 or 1, doesn't matter, it just should be beneath the health bar and the icon. Then let's go to the background image and let's go to the draw as here, because there we want to select none. Then go to the fill image, draw as an image, and let's have a look at time bar fill here. Let's give that a percent of 1 now. And again you'll see that it's blue. Let's change the color here to white. Hit OK. So that's displaying properly already. What I want to do now is just scroll down to the render transform and give it a little bit of a shear in X. So maybe minus 25. Yep, that looks cool. And that's it for designing our widget. Let's compile, save, and head over to the graph here. And if you're only seeing 3 variables here right now, you will need to go back to the designer, grab your text, let's call that name text, and check the is variable here. So now that will appear in our variables list as well. Right, we only need one custom variable in here, that will be the assigned companion. that this widget was created for. Variable type will be master companion reference. Then let's create one function here called update health bar. And what this will simply do is we will get our health bar and set the percentage of that. And to calculate that, grab our assigned companion, get the health, and also get max health. We will convert both of them to a float. Copy that, paste it here. And then we will divide our health by the maximum health to get our percentage, plug that in, and return afterwards. Compile and save this. We will hit Ctrl W to duplicate that and call it update time bar. Set percent node will stay here, but instead of updating the health bar, we want to grab our time bar, connect that to the target, and remove the health bar. And instead of getting health and max health, we want to grab our past time and the lifetime, the variable, not this function here. Then we want to divide our past time by our lifetime. And because we want to start our bar with a percent of 1 and then slowly decrease that, we want to have 1 minus that result here. So let's look for float minus float, type in 1, and then connect our past time divided by lifetime to that. And this will feed into the in percent then. After that, we can remove our health and max health and line up our nodes here. Compile, save, close our two functions now, and in the event graph we want to add a custom event called initialize. Give that one input, which will be the assigned companion. Type for that again master companion reference. First thing that we need to do is set our assigned companion to that input. So we're just promoting that to a variable basically. And then we want to update a couple of things. So let's get our companion icon and set brush from texture. For the texture, let's just grab the assigned companion. And you might remember that we created an icon variable in there. So let's grab that here, hook that up to the texture, and that's it. Then get the name text and set text of that. Here we want to use a format, and that format will be in curly brackets name, then add a white space, then in common brackets LVL dot, add another white space, and then in curly brackets level. Now we see the two pins, name and level. So let's grab the values of our assigned companion. We can grab our name, grab our level, and the level should be converted to text first. Can also expand that here and uncheck use grouping. Plug that in for the level and the name for the name. That's it. After we updated those two things, we can update our health bar and our time bar. And just so you don't see that widget updating, we'll go to the designer, select our W companion, the root here, set the visibility to hidden by default. And after we executed all of that functionality, we will set visibility of our cells to self-hit test. Right? Compile, save. Then we'll close our companion widget, go to the main widget instead, to the designer, because we want to add a vertical box here. Add that. Let's call that our companions box. Make it a variable. There's the order of 1. The visibility you can set to hit test invisible, because we don't want our cursor to interact with the companion widgets. Then we will check size to content, and the position will be 0 in X and maybe 196 in Y, just so that it is beneath our buff box. Okay, head over to the graph. Let's add one function called create companion widget. This function will have one input and one output. The input will be the companion that this widget should be created for, and the output will be a widget. So for the companion, the type will be master companion reference again, and for the widget, this will be w_companion reference. Okay. What we will do here is very simple. We just create a widget. Class will be w_companion. After that, we want to initialize our return value. And you see it's asking for the assigned companion that will come from our input node. After we initialized it, we want to add it to our box. So let's grab our companions box, add child to vertical box. The content will be the return value of our create node, and also feed in the return value into our return node for the widget here, then hook everything up, and that function is completed. We can hit compile, save, and that's it for this episode. In the next one, we will then implement all of the logic for our companion so that we can spawn it, it will follow us, and if we are attacked, it will attack the enemy for us. See you in the next episode.